All right, thank you so much, Louis and Joseph, for joining me. And we are going to study some basics concepts of the peptide synthesis. So before going to the peptide synthesis, I want to ask you one question. What is condensation? Louis, what is condensation? What is
Oh,
condensation? Reaction.
condensation, losing water to make bond between peptides.
Oh, search your notes. Yeah. What is condensation?
Isn't it gaining water?
No, I
Like,
mean, just simple statement. There is just one simple statement that two things combine together by the removal of water,
water.
right? So I just in the previous lecture that you saw, in that I explained that. So one glucose and one glucose combine to make remove the water out of it, and once the water is removed, uh, those two things combine and make maltose. Similarly to amino acids combine and make a peptide, right? Is this concept clear, Louis? Hmm? So what did you
Yes.
understand by this?
To make a bond
All right, very
by
good.
losing the water molecule.
Yeah. So that is actually the basic fundamental principle. But before that, we have to ask a basic simple question. What is reaction?
What is the action?
Reaction. Reaction.
Um,
Wow, you can answer. No worry, no worries. You can answer. What is reaction? Chemical reaction.
when one compound interacts with another compound, producing a third or fourth compound, changing,
Wonderful.
changing the chemistry of that compound.
Yeah, that's wonderful. That's wonderful. And what is your answer, Louis?
Or just one something
Mm-hmm.
reacting with another one
Mm-hmm.
to make a new one.
Okay, that's wonderful. So let me share my screen. So this is, let's say we have H2, okay, and then we have O2, O2. What is H2 and O2?
Together.
Yeah, they react, okay. Insert maybe a shape. Where is the shape? Shape. There is no shape. Okay. Okay, fine. Let's see. Okay, and then it makes water, right?
Yeah.
Okay. H2 and O2 combine to make water, and then we say that here it should be two, and here should be two. So 2H2 plus O2 makes 2H2O. Is it clear?
Yes. Oh, by the way, I just got the email too.
It's okay. So 2H2 plus O2 makes 2H2O, right? So these are called reactants, and this is called product. Okay. Now my first question is, what is mole? Noise. What is mole?
Um,
If you don't know, just say I don't know. That's it.
the amount of substances.
The amount of substance. That's good. That's good. That's good. Yeah.
I know it has, doesn't it also have to do like the amount of atoms?
Amount of atoms. Fine. Fine. So I define it as these are the things that you have to learn very. I mean, these are the very fundamental concepts. Mole is really amount of substance. Louis is very right. But how the mass of a substance, all right, atomic mass of a substance expressed in grams makes it 1 mole. For example, you see hydrogen. What is the mass of hydrogen?
1 gram.
One?
No.
Yeah, one. It's
Yeah,
one AMU. One AMU, right? And if I make it 1 gram, so I will say that 1 gram hydrogen is 1 mole of hydrogen. Okay? And same is the case with oxygen. So oxygen is O2. Oxygen is O2. One oxygen is 16. One oxygen is 16. O2 is 32 AMU. Got it? And I will, if I have 32 gram of oxygen, I will say I have 1 mole of oxygen. Got it? So for example, we have H2O. So that is 2 hydrogen, 1 oxygen. How much it should become?
18.
18. So 18 AMU is this mass. So if I say I have 18 gram of water, what does it mean?
1 mole of water.
That's it.
Oh,
Got it? So I mean, if I want to describe this reaction, I will say that 4 gram of hydrogen reacts with 32 grams of oxygen to make 36 gram of water. Got it? And I can also write this way as 2 moles of hydrogen reacts with 1 mole of oxygen to make 2 moles of water. Make sense or no?
makes sense.
Make sense?
Yeah.
Lois, does it make sense? Yeah. So we can that is so here what I actually want to explain you is what is scale. What is scale? And secondly, I want to say what is actual yield and what is theoretical theoretical yield. Okay, got it? So I will say if I say that will be I am making 2 moles. I am making 2 moles of water. Got it? So I will say that this is 2 mole reaction. This is 2 mole reaction. So the end product of 2 mole reaction will be how much water?
2 moles of water.
Well, like if I make 2 moles of water, how much water should I have in quantity?
Uh, 72
No, no,
gram.
no, no, no. So 80 water is 18,
Water's 80.
18, right? So if I say if I do this reaction, like if I combine 4 gram of hydrogen and I react it with say, 32 gram of oxygen, how much water will I get?
36.
36 gram. 36
Yeah.
gram. This is called actual yield. This is called what? Oh, sorry.
Actually,
This is called theoretical yield. This is called what?
theoretical.
Theoretical yield. Theoretically, it should happen that if I mix 4 gram of hydrogen and combine it with 32 gram of oxygen, I should get 36 gram of water. Got it? Yeah. But in effect, when we do the experiments, we do the reactions, we actually don't get 36 gram. We actually don't get 36 grams. So in the above reaction, if I say that theoretical yield is 36 gram. Oh, sorry. Uh, so the 30, oh my God. Where is that? Sorry. 36 gram. This is the theoretical yield. But in effect, I just get 5 gram. right? So then I will say that the reaction efficiency is very low. Reaction efficiency is very low. Like the reactants are not reacting properly. That is why, in effect, we should get uh, 36 gram, but actually I am getting 5 gram. Got it? So here we will go for, there is another term which is called what is equivalent, right? This is the third thing, what is equivalent. Okay. Now let's go to the another thing, which is this peptide mass calculator. So first link, I have a peptide which is WR, 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 WR. What is that W?
Tryptophan.
What is R?
Arginine.
So
No.
WR,
Yeah.
WR, WR, WR is what? WR, W4R4, right? Okay. And then I will click. What is the mass?
1386.
1386, right? 1386. So in effect, if I make this 1 mole of this, if I make 1 mole of this WR4, what will be the mass of that peptide?
1386.
Yes, 1386 what? Mole. Please, please be confirmed. Clear that concept. I told you what is mole. Amount of substance expressed in gram is called its 1 mole, right? So I have this peptide which is W4R4, right? And the mass is 1386 AMU. 1386 AMU. So how much should I get in amount?
Thir-
Hmm?
1386 moles.
I want 1 mole of W4R4.
You want 1 mole?
1 mole of W4R4. You are not getting my question. If you don't get my question, just say that I don't get your question.
I don't understand the question.
Yeah. So I can say that. Do you understand this thing that 1 mole of 2 mole of hydrogen is 36 gram. 1 mole of hydrogen is 18 gram. Do you understand that?
Yeah.
So W4 WR4, that was my peptide actually. And the mass was 1386 AMU. I'm just saying how much should I get the mass of WR4?
1386 gram.
Wow, that is what I wanted to hear.
Eh,
So is it a big amount or small amount?
Big amount.
How much in kg?
How much?
In
it's
kg,
1.3 kilogram.
1.38 kilogram. Can you hold it in your hand? 1.38, right? I mean, if I say you get something 1.38 kilogram, so will it be less or more?
less than that.
Huh?
Less than that?
No, you are not getting my question. I ask you to get me 1.38 kilogram of something. Is it heavy? Is it small? You can weight, like where will you put it? Like you will put it in a cup or you will put it in some big thing?
A big thing?
Big thing. Obviously, it's a big amount, right? Right? So if I ask you to make 1 mole scale of 1 mole scale of WR4, so actually how much you are going to make?
1386 gram.
So in effect, we don't make this thing in our lab. It's a too much. It is too much. So then I will change this to 1 millimole. 1 millimole. So if I change it to 1 millimole,
Okay.
then how much it should become? I will just multiply this with, I divide this with 1000. 1386 divided by 1000. So how much it should become? 1.386 gram. Got it? Right? And that will be in fact 1386 milligram. Right? And in our body, the peptide that we use is actually in micrograms. So we don't need to make this much of the peptide. So we use what? 1 millimole. If I make 1 millimole, if I ask you to make 1 millimole of W4 or W4R4, so what I am expecting from you to make?
1 millimole.
Yeah? If I ask you to make
One
1
thing.
millimole of peptide W4R4, how much do I expect from you to make?
Making 1.36 grams.
1386 milligrams. Like I want from you to make this much, right? Right? But we don't need this much. We actually don't need this much. So then insert an entire row. Okay. So I just ask you to make 0.2 millimole. How much will you get? Just calculate it and answer me.
2.6. Around 2.6
2.6 what?
milligram.
How did you calculate it?
I thought you said 2 millimolar.
No, no, 0.2 millimole.
Like 2 millimolar.
About 207
I can just,
milligrams.
so if I have to make 0.2, I will divide it by 5. No?
Yeah, 277 milligrams.
And if you have this much amount, how much microgram it will become? Equal this, multiply by 1000. So it's too much. Got it? Got it? So when we do the peptides, so in our body, for example, if I ask you to check the concentration of the neuropeptide Y in the blood, Google it and answer me. Concentration of neuropeptide Y in the blood. Yes, Louis. Or maybe you can check concentration of the, I mean, I can do it with you right now. Concentration of um, oxytocin in blood. What is that? It's in units, so units is too much. So yeah, so you see that 12.1 microgram per ml, right? So usually these things are in micrograms, micro units. It's micro unit, and unit should be very less amount. So we will have to dig out what is unit. So in that case of oxytocin, what I'm trying to say is that we need very little amount of the peptide that we actually need to administer to the patient. So we don't need to synthesize 1.38 kg of the peptide. So we actually synthesize at 0.2 millimole scale or even zero point 0.3 millimole scale or 0.1 millimole scale. So we synthesize at that. But if I ask you what is scale, You should know that what I mean by scale. What do you know by scale?
A way to put everything in the same like level
Can
of
you
playing.
be a little loud?
What was that?
Can you be a little loud? I cannot hear you.
Oh, I guess like make it so everyone is describing the same thing. Does that make sense?
Yeah. So scale, like if I'm saying, like if I just sent you the lab and I say you that make 2 millimole scale of W4R4, what will you do? How much amount of the peptide I am expecting from you to make?
If you're saying 0.2 or 2,
2 millimole.
um, 2.772 grams.
Yes. Right? Got it? So this is the first fundamental concept that you have to learn in chemistry lab. Wherever, whatever you reaction do, the scientist will ask you, what scale are you making that thing? So scale means mole. Scale means
Mole.
mole. Like how much how much do we need? So when we are talking about like on the mass level, if I am making peptide for the millions of the people, then I have to synthesize that peptide in kilograms. But if I am just making that for my experimental purpose, I have to use it like very little amount, maybe in milligrams, right? So now I said that, so that is theoretical yield. That is what you are saying to me is theoretically. If I ask you to make zero point 0.2 millimole, theoretically you will get 277.2 milligram, right? So this is theoretical yield, 277.2 milligram. But in effect, you get, let's say, just 50 milligram. So you can easily calculate the efficiency. Just you divide this actual yield will divide theoretical yield multiplied by 100. That will become your reaction efficiency. So reaction efficiency will be equals actual yield actual yield divided by theoretical yield multiplied by 100. So let me do that. So what I am doing that, so I can do it here like this. So equal, uh, let me see. No, I cannot do it. So I have to remove the milligrams from here. 50, and I have to remove this as well. Milligrams. So that let me do that. Equal this divided by this multiplied by 100. So 24.8% is the actual efficiency of this reaction. Got it?
Yeah.
So, and usually it happens. Usually it happens. So
But
in order to avoid this, so we actually do what? We increase the reactants. What we do? For example, if I want to get 36 gram of water, I want to get 36 gram of water. So then I will not use 4 gram. Rather, I will use 16 gram of hydrogen, and I will use like maybe 32 into 4, 3 fours are 120, like maybe 128 gram of gram of oxygen, and then I will be able to get 36 gram. So I am using it in excess. So I am using 4 time excessive reactants, right? So instead of using 4 gram, I am using 16 gram. And if instead of using 32 gram, I am using 128 gram, right? So this is called excess. This is called what?
excess.
Why do I am using excess? So that I can get close to my uh, actual yield, right? So that I can actually get 36 gram. Got it? So the second thing is excess, which is also called equivalent. So what is equivalent or excess? So I will just say that the the excessive amount of reactants used to make the product. Okay, it
Wouldn't
can be.
I have a
It can
question.
be, yes, it can be 3 times, 4 times, 6 times, 10 times, and it comes with experience. It comes with experience. So when we do the experiments, so we experience something. I react one thing with another thing, and I calculate the product, and if I see that the product is not coming that much, then I will have to use the reactants in excess so that I can get the product accordingly. You got my point? Yeah? What is your question now?
I was just wondering, wouldn't that still make your percent yield low though?
Yeah, percentage yield will be low. Yeah, definitely.
But it's just you want to have more of
The
the
pep,
product.
yeah, more of the peptide. So that is why I'm using excess.
Okay. I was just wondering because I thought you were trying to do that in a way to make the percent yield higher. I was
Yeah.
no, that makes sense though.
No, no, it is not going to make percentage yield
Yeah,
high.
exactly.
The
I'm just
percentage yield will remain same. We are just increasing the amount of the product more,
yeah. Okay. Okay. Perfect. I got you.
right?
Yep.
So, Luis, are you understanding or is it boring?
Yeah, I understand.
Now I revise it. Now I revise what I taught. First, you have to understand what is mole. Whatever is the mass of substance, you just convert that mass into gram. That will become its 1 mole. Got it? Got it? So if I ask you, there is H2SO4, H2SO4. What will be the mass of H2SO4? Like how much? If I say you make 1 mole of H2SO4, like say you have H2SO4. So what will be the mass?
Okay.
So I will tell you 2. It will be equal to 2 plus 32 plus 64, right? 16 fours the 64. Sulfur is 32 and 2. So that is 98 gram. Got it? So if I ask you glucose, let's say glucose, the glucose is C6H12O6. Am I right? So equal 12 into 6. Oh my God. Okay. Sorry. Plus 1 into 12. I mean, I think you have learned these concepts in your high school, or no? Yeah?
We have yeah.
But okay, no problem. We are learning again. 1 into 12 plus 16 into 4. Oh my God. 16 into 6, sorry. So if I ask you 1 mole of glucose, how much it should be?
180 grams.
180?
Yeah.
180 grams, right? And these 180 grams have 6.23 into 10 raised power 23 atoms or molecules. 10 raised power 20, 10 raised power 23 molecules. And that is called Avogadro number. But it is not our topic at this moment. 1 mole of any substance have this number of the molecules, atoms, whatever we say. Got it? Got it? So if I ask you now, uh, let's say we have a peptide which is called CGKRK. Got it? So I want to ask you to tell me the mass of 1 mole of CGKRK. What will you do? You will go to peptide mass calculator and you will write here CGKRK. What is the mass?
590 grams.
590. So I will write here 590. So what should I write here?
Grams.
Wonderful. Got it? But if I ask you to make zero point 0.3 millimole of CGKRK, how much it should be?
177 grams.
I don't know. How did you calculate it? You just tell me.
I multiplied 590 by 0.3.
590 is 1.
Oh, divided by 1,000 multiplied by
First
0.
we have to divide by 1,000. 590 divided by 1,000. That becomes 1. That becomes 1 millimole, right? This is 1 millimole.
0.
And then I will divide it with, I have to make it 0.3.
I just multiplied it by 0.3 because it's like.
Wonderful. So I will just multiply it with 0.3. So that will be this 0.117 gram. So if I want to make milligram, so what will be? It will be this multiply by 1,000. 177 milligram. You're getting me? Yeah?
Yeah.
So now let's do some practice. Can you share screen? Joseph, can you share your screen?
It says you disabled screen
Okay,
sharing.
I am making you co-host. More allow. Okay, more allow make host. Okay, yes. Okay, now you're host. You can share screen. Okay, so I told you yesterday go to Google and check the sequence of the oxytocin. Oxytocin sequence. Copy this. Good. Copy this. Go to peptide mass calculator. Put this here. If I say you to make 0.2 millimole of oxytocin, how much oxytocin you will make?
You said 0.2.
Yeah, 0.2. Yeah, 0.2.
0.2. Yeah, 0.2018.
Huh? Yeah, show me the calculation. Go to the Excel and do the calculations.
So the mass was.
Go to Excel.
And then divide that by 1,000. And then
Multiply by 0.2.
yeah, that's what I got. 0.2.
Yeah.
That's what I got. 0.
Show me the screen. I want to see the screen.
Can you not see it?
Yeah.
Oh, I have it. There we go. I'll do it all over again.
Okay. Just share the screen first. I cannot see your screen.
You still can't see it?
No, I cannot see it. Lois, can you see that?
You need to not you need to disconnect the share screen and then redo it.
I got it.
So do it. 1009. Just make 109 divided by equal. First put equal. First put equal. 1009 divided by 1,000. Multiply by 0.2. So that is
Yes.
0.2018 grams. So now convert it into milligram. So go to the next column, next column, put equal. Yeah, put equal. Take that column, yes, select that column, yes, multiply by 1000. So that will be milligram. You got it?
Yeah.
Yeah, it's easy.
Yep.
Okay, now stop sharing and I will do my sharing now. Okay. Uh, I am the host or no? Can I share screen? Oh, sir, you have to make me host again. Okay, thank you. So now let me share my screen. Share screen. Okay. So now I am going to show you something here, which is that documents. Where are my documents? Okay, documents. Yeah, this is it. So this is here. No, 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 not this one. This one, not this one. This one. So first thing is calculations. First you have to do the calculations. I don't know where is that. CGKRK. 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 I don't know. I'm sorry. You have to wait. Don't worry. Mm. Yeah. So this is synthesis protocol. Now, what we have is here, for instance, this. So what we do, scale means what? So for example, we have KRKGC, right? So this is the peptide. And molecular weight of K is 486.46. Molecular weight of arginine is this. Molecular weight of K is this. Glycine is this. And this. So I am making at 2 scale. Scale is what?
2,
And excess I am using what?
6
6. So how much should I weigh this?
grams.
Milligram. So I will weigh 5623 milligram. Your 5.6 gram. 5.6 gram.
Yeah.
Gram.
Oh,
Got it? Or no?
it is.
You got it?
Yeah.
Yeah? So this is the how we will weigh. And these amino acids come in this form. DDE, lysine, FMOC, OH, FMOC, cysteine, tretyl, OH, FMOC, glycine, OH. Now, what are these things? I will explain you. Okay? So for now, I want you to learn these things. Uh, sorry, learn these things, which is this. You should know what is mole. What is mole, Kim?
Uh, the mass of substances expressed in gram.
Is called
The mass
Kilograms.
no mass
that
of substance expressed in gram is called its 1 mole.
is
Like that compounds 1 mole, right? If I ask you to make 1 mole of something, you will just ask me what is the mass of that something, and then you will just put gram with that. Got it? Yeah? Or you're getting me now? Can I ask you a question?
yes,
What is the 1 mole of CGKRK?
one more.
No, no, no. See, you didn't listen to me. I said whenever someone asks you to make 1 mole of something, what will be your question?
What's the mass?
What is the mass? What is the?
What is the mass?
Okay, and if I give you the mass, what will your answer?
What is the mole?
Oh no, you are not getting me. So let's say, do ask me that 1 mole of CgKRK. What is 1 mole of CgKRK? Ask me this question. 1 mole of CgKRK.
What is the 1 mole of CG something K? CGRK?
KRK. KRK.
Huh? Yeah.
KRK.
GRP?
KRK.
KRK?
Yeah.
What is the 1 mole of KRK?
I will ask you, what is the mass of KRK? You just give me an arbitrary number.
90?
So, 1 mole of KRK is 90 gram. Got it? Yeah. So now I ask you. Now I will ask you and you will ask me. Okay. What is the 1 mole of CgKRK?
What is the mass of the CGCRK?
590.
590 grams.
Of CgKRK is its 1 mole. You got it? Oh, no, you didn't get it. Okay. Now I ask Joseph, what is the mass of glucose? Oh, sorry, what is 1 mole of glucose?
What is the mass of glucose?
180.
1 mole of glucose is 180 grams.
So if I ask you, Kim, what is the mass of sulfuric acid?
Mass?
Sorry, what is the 1 mole of sulfuric acid?
What is the mass of sulfuric acid?
98.
98?
Yeah.
So 1 mole of sulfuric acid is 98 grams.
Wow, you learned it. Does it give you confidence? Yeah.
Yes.
Let me do now. Let's do some different things, right? I have this peptide YRYKWCG. What is the mass of this thing? What is 1 mole of this thing?
What is the,
Bingo.
Yeah.
what is so 1 mole of that thing is 974.432 grams.
Wow. Clear? But it is too much. If I ask you to make 1 millimole of this thing, then
That is very.
you will just divide this number with 1000.
Is it a multiply?
Millimole. No, when we convert mole into millimole,
Oh, millimolar, so 0.974.
yeah, 0.974 gram or
Gram.
974 milligram. Okay. And if I ask you to make 0.1 millimole of that, so you will just multiply that with 0.1. That should be very much clear. Got it? Or no?
I got it.
This gives you confidence or no? Okay. And let's take a break for 5 minutes. And I'm stopping recording. Okay.